Hey there, I'm just going to show you a presentation I gave at the launch event for Green Software Ireland back in May of this year. It covers some of the steps we're taking at my company, Tixserve, to reduce the carbon footprint of our software. Enjoy. Tixserve's been around for about 7 years now. I've been with them for the last 3. We're an Irish scale-up who do the digital distribution of event tickets, say tickets for things like concerts, sports events. And we typically have a fairly low level of activity week to week, but during events we see a massive spike in that. So you imagine 60,000-70,000 people approaching a venue for a concert 2 to 3 hours out from the time the concert starts. That's the kind of thing we have to deal with. So we typically provision our services to handle that, and all our services are on AWS, so we try to take advantage of things like auto-scaling and that on there. And the main goal of the project is to reduce waste at the company. So we're going to look closely at what we're doing now, measure that carefully, and then look at ways that we can reduce the energy usage and carbon emissions of our software, whilst always being mindful of the service that we're delivering to our customers and their end users. We're using Impact Framework from Green Software Foundation to measure the carbon emissions of our software. It's a really nice tool that will enable us to measure over time the progress that we've made. Green Software Foundation produces some really nice tools and resources for the community, and Impact Framework is another one of those. It's open source, and there's a nice collaborative feel about the development of the tool and the ethos behind the tool itself of sharing manifest files and getting collaboration on projects like ours. An early decision we made on the project was deciding what to measure. This was important for a couple of reasons. We wanted something that would be relevant to us over time, so as we made changes to the system, that this measurement would still be relevant and reflect the carbon emissions of the software at that time, and we could compare it to the past. We also wanted it to be relevant to the business domain. So I've picked a couple of measurements here. One would be grams of CO2 equivalent per read-write operation on the database, and another one is grams of CO2 equivalent for every ticket journey. A ticket journey is a user registering on the app, downloading their ticket, and then using that ticket to access the event. I think the second measurement is more relevant to the business domain, the ticket journey one. It's the core of our business, delivering tickets to users and getting them safely into an event. And that probably won't change over time. So this feels like it would be the most reflective of how we're doing in terms of the software, the carbon emissions of our software. I'll get into each of these steps in more detail later on, but just to kind of give you a bit of an overview of the approach to using Impact Framework to measure carbon emissions of software. Step 1 would be to collect the data, then to determine the pipeline that we're going to use in Impact Framework, set up those plugins, and finally using the Impact Framework to get an output and to read that output. Getting the data from AWS was pretty straightforward. AWS CloudWatch allows you to access a lot of stuff like CPU utilization and read-write ops, etc. Formatting the data then for use in Impact Framework was also fairly straightforward. A pretty simple Node script to convert from CSV to YAML and to get the data into a format that Impact Framework could use. Impact Framework uses a pipeline to bring you from the input data that you have already to go to the output data that you want. In my case, I wanted to go to get the SCI score of my software for the metrics that I decided on, and the input data was coming from AWS. There are some values created in the middle by Impact Framework, and these are then used to help calculate the final output score. The next step was to set up the plugins, and this is relatively straightforward. I go into it in a little more detail on the actual demo of how to do all of this. But as you can see there, we've got a few plugins, the Teads AWS, SCIO, Sum and Divide, and they have inputs on one side and outputs on the other. We finally then get our output, which is also in a YAML format. You get an array of data from the pipeline, and that is going to show us our SCI rate of carbon emission and the aggregates as well for total energy and total carbon. Okay, so here's a quick demo of the Impact Framework using Tixserve's manifest files. I've got our 2 manifest files over here in a manifest folder. We've got ticket journey and weekly RDS. We'll have a look at both of those. I'll start with weekly RDS. Weekly RDS is going to give us an aggregate of carbon and energy for the week at Tixserve on the system we're testing. It will output to YAML. We set up our plugins, Teads AWS, SCIO, sum and divide. And then we have our pipeline, which is Teads AWS, which gets run first. That gives us our energy usage and operational carbon, embodied carbon. SCIO then gives us our operational carbon. We use sum to add operational and embodied carbon together to give us total carbon for each input, and then we use divide to give us our SCI score, which in this case is where is it? Grams of CO2 equivalent per read write on the database. The defaults, I've given it the defaults, are the M5X large, that's the size of the database instance type that we're using on AWS, and the grid carbon intensity, which is the grams of CO2 per kilowatt hour in the region where we are hosting this. That's just an average. We could use an API to get this value, but we didn't have time to set that up. So we're using a good default, which is 132, that's for London. So these are our inputs here. We'll go just have a close look at the first one. We have a timestamp, duration of 300, that's seconds, so 5 minutes. CPU utilization is an average CPU utilization in those 5 minutes of 3.29%, and then the number of read-write IOPS during that time, and that's 2542 total. That goes all the way through the week in 5-minute intervals, and that's our total inputs from this particular manifest file. If we look at ticket journey, it's something similar, although we're using Teads AWS again, SCIO, and sum and divide. However, our SCI value is slightly different. It's going to divide carbon, the total carbon of each input, by the number of ticket journeys. And that will give us an SCI, which is the grams of CO2 equivalent per ticket journey. The pipeline again is Teads AWS, SCIO, sum and divide, and the defaults are almost the same. We've got a cloud instance type M5X large, grid carbon intensity of 118.5. Now that's because typically events will for us happen in the afternoon, so the grid carbon intensity would be lower than normal. It doesn't, possibly because there's more solar energy available at that time of the day. The ticket journeys is the ticket journey per minute that we can process, and that is 446.9, not quite 450, because the total time that this manifest file covers is 179 minutes rather than 180. And again, we have our inputs, which is a timestamp, a duration, and a CPU utilization during that duration of 9.595. Let's get to the fun part, which is going to run it, and we're going to use Impact Engine, IE. I've already run this one before, so I thankfully don't have to type it in again. But we're going to run IE on the manifest file ticket journey, and we're going to get an output of ticket journey. I'm going to just remove this last piece here, ticket journey. Okay, right, enter here, and it should run with some errors because of Teads AWS, and that will give me an output file up here, which I'll open now. And as you can see, it's almost identical at the top of the file, has all the same values that we saw previously. Our inputs are all there as well. I have to scroll through this quite quickly, inputs, and we get to our outputs. Right, so we'll have a look at the first output. Again, we have the output will show our inputs for this period, which is a timestamp, duration of 60 seconds, CPU utilization 9.595. Now it adds in our defaults, the cloud instance type M5X large, grade carbon intensity of 118.5, and the ticket journeys of 446.9. Now we start calculating. So Teads AWS gives us back our energy, which is kilowatt hours, and that's what we used in that minute, 0.0002. Carbon in the embodied carbon. In that minute we used 0.0319, and the operational carbon was 0.0272 grams of CO2, grams of carbon. And that gives us a total carbon value for that duration, for that period, of 0.05915. So that's using the sum plugin. And finally, we get our SCI, grams of CO2 equivalent per ticket journey, and that is 0.001323. Okay, very small numbers, but still relevant, and over time we'll be able to calculate how those change. If I scroll right down to the end, so we can see that every input has an equivalent output. After running through our pipeline, now we get to the aggregation part. And at the very, very end, I will see aggregated total carbon. 10 grams of carbon, 10, and then energy 0.0423. Okay, kilowatt hours. Okay, so that's something then we can, the plan is to make changes and see what the impact of those changes are by running this manifest file again. Obviously we'll change, the inputs will change, but the pipeline will remain the same. And the beautiful thing about the impact framework is we can publish this, which I have already, on GitHub, and you could download and run this yourself, and you could even modify it and give feedback to me about alternative ways I should be or could be using to measure the carbon output and energy usage of our system. At this point, I'd like to make a little commitment to you for this project. I've already achieved part 1, which is to publish this presentation, but I'll be reporting back at our next event for Green Software Ireland, which is on September the 11th. It's an online event. You can find us on Meetup. I'll stick the link in the notes of this video. I'll also share the approach and the results as I go through the project. And finally, we'll publish the outcome to show what we achieved overall. Okay, just to finish up with some info, the next event for Green Software Ireland is on September the 11th, 2024, and that's at 7 p.m. Irish summertime. That's 8 p.m. UTC. Everyone's welcome, so you can sign up at our Meetup page, which the address is on there, meetup.com/Green Software Ireland. Thanks for listening. Let me know if you have any questions. I'll put all the links and information from this video into the description.